Hello, welcome to Mathy Python. This week we're looking at dictionaries and sets, and these are the solutions to the worksheet that is on my GitHub page if you're following along. First one says create a dictionary that maps first five prime numbers to their squares, access and print a square of 3. So the primes, first 5 primes, 1, 2, 3, 5, 7. And then square primes for I and primes, square primes of that key is I squared, and then I output it. So square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 5 is 25, square of 7 is 49. Okay, given a dictionary, student, it has a key of name that's mapped to Alice, key of grade mapped to A, scores mapped to 92. We want to do various things with this, so add a new key, pass with value true, update the score to 95, delete the grade key, and then print it out. So student, I just copy paste this from the problem. To add a new key, you just assign it. The student of passed is equal to true. Now it's in there. To update a value, student of whatever the key, the dictionary of its key is new value. So student of score is 95. To delete the grade key, I use del for delete, so delete the student grade. And then to make sure all of that actually worked, we output it, so the name is Alice, the score is now 95, passed is true, and the grade is no longer in there. Given a list of words equals, here's words in a list, some are duplicated, like the apple. Find a set to find the unique words, then print them in alphabetical order. Copy paste the list of words unique. Let's work from the inside out. So I have a list of words, turn it into a set, cast it to a set that gets rid of the duplicates. I can cast that back to a list. So now that it's a list without the duplicates, and then sorted will return a dictionary a list that is sorted. And then I output it, and sure enough, we get apple, banana, cherry, no dupes, and it's alphabetical. Okay, what will this print? So here's a very generic dictionary, A mapped to B, A mapped to 1, B mapped to 2, C mapped to 3. Print A and D, this is true, false, is A in the keys of D. You could have put D dot keys. If you leave off the keys, then that's filled in for you. So print A and D, that's true. Print 1 in D, 1 is not a key. It's a value, but it's not a key, so that's false. And then print 1 in D dot values. Now we're asking, is it in the values? And yes, it is. So we can see that in fact we did get true, false, and 5. We are given 2 sets. We have the primes and some odds. Print the union intersection difference of primes that are not in odds and symmetric difference. So primes is 2, 3, 5, 7, 11. Also copy pasted the odds. The union is the bar, which is an or. You can think of it as an or. Intersection is and. Difference is primes minus odds, so those that are in primes but not in odds. And then the symmetric difference is everything not in the intersection. Problem 6. We're given a dictionary here of scores. Using loop and items, print each student's name and score, then find and print the name of the student with the highest score without using max. Okay, so here's the dictionary. To print it out, use scores.items. items will return a key and a value. I give the key and a value a name, so student score and scores items, and then print them out. There they to find the highest, initialize the highest student as a blank high score, -999. There is no score, -999. So that can't possibly be the high score by accident. Loop through again through the items, print it out. If the score is greater than the high score, then the high score should be that score. And look, and the student, grab the student for the high student, and then print it out. Okay, so I printed out the dictionary, and then the high is Dave with 100, which is true. Number 7. Given a string, build a dictionary that maps each unique character to the number of times it appears. Test it on Mathy Python and ignore spaces. Right, so Mathy Python frequency dictionary is empty. Now we're going to build it up with a for loop. So for C, standing for character, and S, which is our string, but not just S, I'm going to replace a space with nothing, so that gets rid of the spaces. And let's also make it lower. Not really an issue with this particular string, but it could be that there's a capital L and a little l or something in it. So we step through the characters. If the character is not already in our frequency dictionary, then we put it in there. We initialize it to 1. If it is already in there, I don't want to overwrite it, so I just add 1 to that value. Print it out, and we see M is 1, A is 1, T is 2. There's a T here, and there's a T there, and so forth. Problem 8. Given this dictionary of inventory and how many apples, bananas, cherries, and dates, use get with the default value. To safely look up the quantity of apples, grapes, and dates, print a message for each saying either quantity or not in stock. The point of this is that when you use get, if the item is not found, then instead of throwing an error, it just returns a message. So you can safely look something up. And if you don't find it, you just say so, whatever appropriate message you want. So we have the inventory here to look up items, the items we want to look up. I step through these lookup items, so for item and lookup items, and then print get the item, which will get the value of the item, or like I said, if it's not found, I'll just say not in stock. So apples had 50, grapes, there are no grapes in there, prints not in stock, and then dates, it prints out 15. Number 9, given 2 sets of students, math class, Python class, each is set with some students in it. Find the students in both classes, in math but not Python, students in either class but not both, and the total unique students across both classes. So I copy paste the sets in. Both classes is the union. So with if you're thinking in Venn diagrams, that would be both bubbles. So math class or Python class. So that prints out, let's see, E from math, Bob from math, Dave is in both, Carol is in math, so forth. So it gets everybody. Either class, we want to know how many students are in either. So we look at the students in math class, but not in Python class. And then the other way around, how many are in the Python class, but not the math class. Get the links of those, add it up, 5 students. So we look at math class or Python class, take the union, and then the length of that, and we get 7. Okay, here we have a nested dictionary. This is common if you're using JSON. It has nested dictionaries inside of dictionaries inside of other dictionaries. It goes very deep sometimes. And then you have to pull out the information and do something with it. So here we have courses, math, 101, and then the value of that is itself a dictionary. So we want to print each course number and instructor on its own line and compute the total enrollment. Okay, so the courses, copy pasted from above. Step through the courses. I look up the course and then the instructor. For the total enrollment, I look up the courses of Math 101 and then its enrollment. So courses of Math 101, that gives me this dictionary. It retrieves the value, which is itself a dictionary. And then I look up the enrollment from that sub-dictionary. So that'll give me 32. And then I do that for the next class, which is 25, and the next one, which is 18, add it up, and I get 70. Problem 11 is an inverted index, a reverse lookup. So given this dictionary of students and their grades, make a new one that has the grades and then the name of the students who had that particular grade. A little wrinkle in this one, there can be multiple students that have the same grade. So Alice could be an A, Dave is also an A. So when you reverse that, you need a dictionary. And then we can have a dictionary that has only one name in it. That's fine. And that will be our solution once we figure out how to do that. So our original dictionary, here it is. Reverse lookup is a dictionary that I am creating. So the idea is that I step through the original dictionary with its keys and values, look up the grade in a reverse lookup if it exists. So if the grade is already in the reverse lookup, so that would be like Alice is in here, but we haven't seen Dave yet, then we would append Dave to that existing dictionary, existing list. And if the student is not yet in the dictionary, then the reverse lookup of the key of grade is equal to student, not just the student name, but the student name within a list. Okay, 12. Letter frequency analysis. Given any string, build a dictionary mapping each letter to its frequency. Ignore spaces, punctuation, and case. Sort the results by frequency from highest to lowest and print them. Test it on the quick brown fox jumps over the lazy dog. What do you notice? So here's the sentence. I look at the characters, which is the sentence. Replace space with a null. That gets rid of spaces. Make everything lowercase. Okay, initialize a frequency dictionary. Step through the characters for character and cares. If it's already in there, add 1 to it, else you initialize it with 1. Then we print it out. And what we'll notice is that every character in the alphabet is used at least once. Problem 13, given a set of numbers and a target, find all pairs of numbers in the set that add up to the target. You do not need to check every possible pair with nested loops. So one way to think about this is that you would start with 2 and then pair it with 7, 11, 15, 3, 6. See if any of those add up to 9. 7 does. Then you would try 7 with the rest of the numbers, 11 with the rest of the numbers. That's very inefficient. There's a better way to do it. So let's think about this. So our numbers, copy paste that, same with the target. Now I'm going to loop through the numbers. And for each, I'll find the number that is needed to add up to the target and then just check if it's in the set. So for number and numbers, loop through 2, 7, 11, 15, 3, 6. The complement, I'll call it, is the target minus the number. If the complement is also in the numbers, print it out. And we get 2, 7, 3, 6, 6, 3, and 7, 2. You see that we had each number pair twice. If you only wanted it once, you could add this set that's seen So, yeah, we again step through the numbers, figure out the complement. If the complement is in the numbers, if it's not in scene, then print it out and put it in there. So that would have, when you start, you would have 2, and it prints out 2, 7. When you get to the 7, it will say that its complement is 2, but that's already been seen. It's already in our set, so we don't need to print it out again. Problem 14, given a list of exam scores, build a dictionary that maps grade bands. So A is 90 to 100, B is 80 to 89, so forth, to the count of scores in each band and print it out as a histogram. So we'll go through it. We'll see how many A's we have, how many B's, how many C's, how many D's. And then we'll go through that again and just print out that many stars. So our scores, copy pasted from the problem, the grade bands initially, 0 A's, B's, C's, and D's, because we don't know yet. We haven't calculated it. And then for score and scores, we step through these. If the score is greater than 90, then the grade bands, you add 1 to it. Else, if it's greater than 80, add 1 to the B's, so forth. Then to print out the histogram for grade and grade bands, print the grade, then print the star times the value of that dictionary for that particular grade. So the grade bands of A would have 4. Grade bands of B would have 4, so forth. So problem 15, word co-occurrence. So given a list of sentences, here we have a list of sentences. The cat sat on the mat, the cat ate the rat sat on the mat. Build a dictionary where each key is a word and value is a set of all words that appear in the same sentence as that word. So, for example, cat should map to the sat on the mat. And then from the second sentence, it also has the words ate and rat. So cat, we build this dictionary and the key goes to this set. So the sentences, copy pasted from above, build the dictionary. I'll call it co-occurring words. It's an empty dictionary initially. Then 4 sentence and sentences. So I'll look at the first sentence, then the second, then the third. And then 4 word in the sentence words. So to get the sentence words, I just split that, make it a set, step through that. If it's not yet in the dictionary, then add that key to the dictionary with an empty set that we'll fill in later. And that gives us a set to put things into if we haven't seen the word yet. And then we union the existing set of that word. So it's itself, and then union all the rest of the words in the sentence, not including that word itself. Then we print out the dictionary. So word, I'll call it co-occurrence, in co-occurring words of items, just print them out. And here we have, so the has on, rat, sat, cat, mat, ate. On goes to the sat, rat, cat, mat, and so forth.